Welcome to Link G4X Training Part 17. In this video, we're going to be taking a look at working with our cranking and our post-start fuel. Now, our cranking fuel is going to be used when the engine's in cranking conditions. We need to deliver a certain amount of fuel so that the engine's going to fire off at different kinds of coolant temperatures. At the cold coolant temperatures, we're going to have to deliver more fuel. At the warmer coolant temperatures, we're going to have to deliver less fuel. So the cranking tables are going to allow us to accomplish this. Now, once the engine fires off and it gets above 400 RPMs, we're going to transition into the main fuel table. Now we're going to be using something called the post-start fuel enrichment tables to add fuel on top of or against our main fuel table for the first 5 to 30 seconds after the engine fires off, so it has stabilized combustion. Then we're going to be tapering into our warm-up enrichment. After the engine warms up, we'll finally move into our main fuel tables. So there's going to be an order of operations of how all of the cranking fuel and post-start fuel tables are going to work. We're going to go through everything in the video here, so it's going to be very clear what to edit when you're doing your calibration process. So without further wait, let's jump into our video so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our cranking and post-start fuel within our PC Link software. Now let's talk about our cranking fuel. When we're in cranking conditions, so less than 400 RPMs, the engine hasn't fired off and it ran yet. We need to go and add additional fuel so the engine's going to be having enough fuel to fire off, but not too much fuel that we flood out the engine. It's going to be varying how much cranking fuel we need based on what kind of coolant temperature we're operating in. Colder coolant temperatures, we have our wall wetting effect going on because the atomization is very poor with the fuel, and we're finding we're going to have to pump up our cranking enrichment. And then as we get up to the hotter temperatures, 170, 200 degrees Fahrenheit, we're going to find that we can run less cranking enrichment because we're finding that atomization of the fuel is much better. So the cranking fuel is going to be used to get the engine to fire off. Now once the engine's actually fired off and is running, so it's above 400 RPM, it's going to move from the cranking fuel enrichment into the post-start fuel enrichment. That's going to be adding a percentage of fuel for the first 5, 10, 20 seconds, depending on how we program the post-start enrichment. And it's going to be allowing the engine to stabilize the combustion. Once it's stabilized the combustion, the engine's going to be operating and holding a steady idle. It's going to be then dissipating. There's going to be a decay period with the post-start. It'll then move into our warm-up enrichment. That's going to be adding additional fuel until the engine has came up to operating temperature. All of this is needed to overcome that wall wetting effect on a cold engine. On a warm engine, we're still going to find that we have our cranking fuel, our post-start, and potentially warm-up enrichment depending on where our coolant temperature is going to be falling in line. But we'll find that the post-start and warm-up enrichment are going to be much less on a relatively warmed-up engine compared to looking at a cold engine. So this is used only under starting conditions. It's going to be used for the first maybe 30 seconds to 60 seconds, maybe even 90 seconds. If you're firing it off from a bone cold engine that's sat overnight, it's going to be taking a little bit to get the engine up to operating temperature. But once it goes into the normal operating temperature, it's going to be in then our main fuel table. So let's go and actually move from our basics page here. We're going to move across into our page labeled f.trim. This is going to be our fuel trims page. We were in this particular page in our last video talking about our warm-up enrichment table, our charge temp approximation table, and then our IET fuel trim table. So these tables were covered. We're going to be taking a look at essentially everything else on the screen here. I like to have all of my fuel trims within one page here. It just makes it a little bit easier to kind of track down what's going on when you want to do any kind of modifier trims or any kind of cranking or post-start fuel. So let's first talk about what we have on screen here. Then we'll just talk about what I have. I have a graphical plot so you can see exactly what's going on moving in the order of operations of how the programming logic is going to work between our prime pulse, cranking, post-start, warm-up, and then tapering into the main fuel table. So looking here at the very left-hand side of the screen, we can find we have our IET fuel correction. That's going to be tying into our IET fuel trim table. We don't need to worry about that. Next, we have our pre-crank prime. This is related to our pre-crank prime table. The pre-crank prime is when we turn the key on or power up the link box. When it powers off for that first second, it's going to be shooting a bunch of fuel out of the fuel injectors in a batch style mode. So all the injectors are going to spray a bunch of fuel very quickly to act as a priming effect. Now we can turn this feature on or off. Right now it is off. In most calibrations, it'll actually be turned off. Then we're going to find here that we have our cranking enrichment parameters that we can program. There's going to be a first crank prime that's going to be sending a huge shot of fuel for the first cranking revolution that the link is going to be syncing. After the cam and crank sensors start to spin around and we register those and we sync, it'll then inject a huge amount of fuel. Then it moves into our cranking enrichment table. We're going to find that our cranking enrichment table is going to be a percentage of our main fuel table. So whatever our main fuel table is going to be at, it's going to be calculating what that base pulse width is and then adding the percentage that we find in the table here. we can take. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.